Dear learners, today we will be discussing about the past climate. Earth is a constantly changing planet since its formation of around 4.6 billion years ago, and hence its climate is also witnessing the changes from time to time. In today's session, we will be discussing about the past climate, since we have seen in the last session about the various sources of paleoclimatic data. And the very purpose of this session is to know the climate change that has occurred in the past, and particularly the climate of the Quaternary period. Once we know the climate of the past, we can understand fully well the various dynamics that is taking place within the climate system. The second important thing is that we can figure out the reasons for present climate change. The third is we can come to know about how to adapt ourselves, how to mitigate the climate change. So a kind of a future perspective is involved in this session. So we know fully well that the changes in climate is neither unusual nor a new phenomenon. It's a natural process. It's a very natural process, and Earth has already witnessed several cycles of climate change since its origin. Before discussing the Earth's past climate, let us familiarize with the geological time scale. Geological time, covering entire span of Earth around 4.6 billion years, is also divided into certain geological time units such as eon, era, period, epoch and age. The duration of a particular time unit of the scale is determined by the dating of rocks using the radioactive methods. The boundary between two time units, between any two time periods, largely corresponds to certain biotic events. It can be extinction of certain species or even the origin of certain species, and that is the most important, the point, the kind of demarcation between two time periods. The rock record of Earth contains numerous clues of the past climate, the sedimentary rocks particularly, and that shows the climate of the living planet. It's always changing. It's not uniform since 4.6 billion years. The fossil records like tree rings, the plant leaves, the pollens, the coral skeletons, ice core data, sedimentary layers, rock layers, and many other depositions or the main substances that contain the proxy data for the paleoclimate. The study of this proxy data, whether it's a fossil record or the sedimentary layers or dendroclimatology or even the coral clock, so all reveal the past climate of the Earth. And the past climate of Earth had often altered by changing solar intensity, volcanic eruption, the plate movement means lithospheric plate movements, weathering reactions also, and also the fluctuations in the greenhouse gases, and that ultimately lead to the changing climate and particularly the temperature. Even the changes in the oceanic circulation patterns, the cyclic variations in Earth's orbit around the sun. I'm talking about the Milankovitch oscillations, the meteorite impacts, and even the biological evolution all influences the Earth's past climate. Let us see the climate in the past, particularly from different periods. The first and foremost important thing is the Precambrian period. And during the Precambrian time, it's a very long period of time. It is between 4.6 billion years to 540 million years, almost 80% of geological time scale, it is in the Precambrian period. And during this particular Precambrian period, the Earth's climate was very, very warm. It was very warm, and the concentration of greenhouse gases like carbon dioxide, methane, water vapor were very, very high. The very important point here is that the greenhouse concentration in the atmosphere was much, much higher. For instance, the concentration of carbon dioxide was more than 18 times than its present level. We look at the present level, it's only 410 parts per million, but during the Precambrian period, the carbon dioxide level was 18 times more. The methane concentration was about 1000 parts per million. Look at the concentration of greenhouse gases. It's very, very high. And that is the reason why the climate during the Precambrian period was very, very warm due to the presence of greenhouse gases. As regards the oxygen, oxygen was not present in the early atmosphere. After millions of years of the formation of the earth, the temperature came down, slowed down to certain degrees, and water vapor of early atmosphere produced the rains. Rainfall, that is the most important thing, because as a consequence of the severe and downpour, what happened, the earth was provided with all the basic necessities like water, that's very important, and the soil and air for the origin of life. And that is the trigger point. So oxygen formation was a trigger point, and earlier, slowly and steadily, only it was formed, oxygen was formed, and thereafter life emerged. When you look at it, around 3.5 billion years ago, the early forms of life, when you talk about early forms of life, it's particularly the microorganisms, the cyanobacteria, made its first appearance on the Earth's surface. Cyanobacteria, we know it is a photosynthetic bacteria. These bacteria made their own food by using the solar energy. That's the source of energy, and it released oxygen as a byproduct. Around 600 million years ago, enough oxygen was present. Now, when I say enough oxygen, because of the photosynthetic activity, enough oxygen was present in the atmosphere, and that led to the development of multicellular organisms. The non-glacial and the glacial stages have been recorded in the Precambrian period, Precambrian history of the Earth. The evidence, the consisting of the sedimentary rocks formed by the glacier movement show that Earth was very, very cold, possibly near to the freezing point during the later part of the Precambrian times. Later part means almost Phanerozoic. So during the later part of the Precambrian period, the Earth was much, much cold. I mean, that is what that we can gain from the proxy data in the form of sedimentary layers analyzing, deciphering the imprints in the sedimentary rocks. And almost 4 ice ages were known in the Precambrian period. The first ice age occurred in the Archean, around 2500 million years ago. It was occurred, first ice age, and thereafter 3 ice ages in the Proterozoic eon between 900 and 600 million years ago. So there are 4 ice ages occurred in the Precambrian period. Now let us see the climate during the Phanerozoic period. It's a kind of a change from Precambrian to Phanerozoic. In the Phanerozoic eon, that's around 540 million years ago to the present, that's called Phanerozoic eon, the concentration of carbon dioxide fluctuated. I mean, carbon cycle started, so it means that the carbon dioxide concentration was fluctuated, so much greatly fluctuated. It means that you can find for yourself that from 6,000 parts per million, I said 18 times more the carbon dioxide concentration, and from 6,000 parts per million it has reached to the current levels. So it was fluctuating, and basically, and this is because of diverse variation that has occurred on the land ecosystem on the surface of the Earth. So that is the very important point here, because the driver here is the carbon cycle. Now, when I talk about the Phanerozoic period, a lot of changes occurred, and when you look at the changes, mainly it's driven by the climate. In the Phanerozoic period, the climate shifted frequently between ice house, that is glacial and non-glacial stages, to greenhouse condition, warm condition, and also the temperature. If you look at it, it is greatly fluctuated mainly because of the natural process, like the movement of lithospheric plate masses. That's the most important, the driving force that has caused this change in climate during that particular period. And also the extraterrestrial impacts also that has occurred in the Phanerozoic time. So because of these reasons, mainly natural reasons, the climate, if you see in the Phanerozoic period, it was highly fluctuating. And incidentally, when you talk about told you earlier also, each and every period you can demarcate it because of by deciphering the sedimentary rock structures, and major event would have occurred between the periods. Perhaps the origin of a life, I mean species, new species, or extinction. And in the Phanerozoic period, if you look at it, 5 mass extinction has taken place. 5 mass extinction. Now we are in the 6th mass extinction. But when you talk about the 5 mass extinction that has occurred in the Phanerozoic history, so the 5 great mass extinctions, such as during the end of the Ordovician period or end of Devonian period, and it's in between the Permian and Triassic boundary also, and Triassic period and Cretaceous period. 5 mass extinction has been recorded in the Phanerozoic history of life. All these mass extinctions are directly related to the changing climate. It's a most important point to be taken into account, because climate also, the change in climate also can cause a lot of catastrophe, and in the form of extinction, if you look at it, it can lead to even mass extinction. In fact, when you look at mass extinction, it's a phenomenon. It's a phenomenon where sudden and permanent loss of large number of species, organisms take place on the Earth's surface. A large number of species, even the families, taxonomic families will be, removed from the Earth's surface. So that is why it is called as mass extinction. It's much more than the background extinction rates. And in the Phanerozoic period, major ice ages, if you look at it, it has been documented, very well documented. And the major ice ages that has been documented in the Phanerozoic eon occurred in the Ordovician period, and also the the Carboniferous and Permian periods also, and the late Cenozoic period also occurred. So 3 major ice ages occurred during the Phanerozoic history, And let us now come to the climate of the Quaternary period. The Quaternary period is the youngest period of the Cenozoic era, and it has been divided into 2 epochs, Pleistocene and Holocene. This is a very important thing because we are in the Holocene period, so definitely we can understand much better from this particular thing. So the Quaternary period, if you look at it, it is a period of greater climate changes, that has occurred since the past 60 million years. So the climate history of Earth since 2.58 million years ago to present, if you see, it is very dynamic. If you see, when I say dynamic, a large portion of the Earth's surface has been covered by ice, glaciers, huge masses, particularly the northern hemisphere, parts of southern hemisphere, also Antarctica, but mainly in the northern hemisphere, and even in the high mountainous region also you'll be finding a lot of glaciers. So that is the uniqueness of this particular period, and that is the reason why this particular period has been called as Great Ice Age. We are living in the interglacial or warm stage of this age, that is particularly the Quaternary period. We are talking about the Holocene epoch. The oxygen and the carbon isotope ratios, even the growth rings of the trees, the cave and the glacial features, I'm talking about the deposits, the lake deposits, dune deposits, the fossils like microfossils or the pollen grains, even the ice cores, all are climate proxies that are commonly utilized to reconstruct the climate of the Quaternary period. So these are the normal proxy data we have used, and we are dependent on those things to decipher the past climate. And now let us see the climate of the Pleistocene epoch. The Pleistocene epoch starts from 2.58 million years ago and it ends at 11,700 years ago. Okay. The study of various climate proxies of the Pleistocene epoch, clearly shows that it was a time of radical, climate changes, and also emergence of human beings. It's the most important thing. The beginning of the Pleistocene is also marked by the first appearance of other mammalian genera, like even the elephant, the mammoth organisms, bovid, horses. These are the other mammalian genera also originated in this particular period, this Pleistocene epoch. The climate of Pleistocene, if you look at it, it has been characterized by an orderly sequence of interglacial, glacial, interglacial periods. So it's a kind of a sequence has occurred in the Pleistocene epoch. During this Pleistocene epoch, the cold climate intensified. it's a severe cold, it intensified, and that led to the development of extensive ice sheets and mountain glaciers also in the high altitude regions and also high latitude regions, both in the north and the south. It's an extensive ice mass were there. If you see the large part of the northern hemispheres, whether it's USA, Canada, Greenland, Europe, Asia, northern Russia, the down south you have Antarctica, South America, and even the mountainous regions of Rockies, Andes, Himalayas, all have been covered by the glaciers. So that is the uniqueness of this particular Pleistocene epoch, wherein the cold climate was very, very severe, and that led to the formation of a lot of glaciers. And if you look at it, nearly 30% of the Earth's surface during the Pleistocene epoch was completely covered by the glaciers and ice sheets. Around 20 alternate cycles of glacial, interglacial stages have been documented in Pleistocene epoch. In the Pleistocene epoch, if you see the tropical regions, particularly in the tropical regions, it received maximum rainfall, and that led to what kind of climate? It's a humid climate in the tropical region, but in the higher latitude, it's very, very severe cold. Because of severe rainfall, what happened? There was a lot of flooding in the rivers and streams, and that led to the formation of extensive flood plain deposits also. Flood plain means I'm talking about you can find the layers of the sand, silt and gravel, these all, because this silt is most finest thing. So the kind of a layers you'll be finding, that is, that you easily can find in the floodplains, and that is also a document indeed. And when you look at the vegetation aspect, the deciduous forest and the coniferous forest were more common during the warm periods. However, the grasses, lichens, mosses dominated during the winter period. And as far as the Pleistocene epoch is concerned, 4 glacial stages and 3 interglacial stages have been documented in the Pleistocene epoch. They are the Kunz, Mindel, Ries and Wurm, European glacial stages. And a very important thing is that many mammalian fauna, woolly mammoth, woolly rhinoceros, and even the Colombian mammoth, cave lion and reindeer, these all they got adapted to the cold climatic condition, and it has been documented that these kind of organisms were there in the Pleistocene epoch. It's a huge animals. And now let us go to the climate of the Holocene, where it's very contemporary in nature, and for a simple reason is that human beings played a very important role during this particular epoch, Holocene epoch. And this particular Holocene epoch starts with the end of the last Pleistocene, that is 11,700 years before present, and continues till present day. So this is about the Holocene, and it is basically Holocene epoch is relatively a warm period during which, yes, the human influences were much higher, and they were in a position to alter the earth system and the environment as well. When you look at it, the humans altered every possible way the environment mainly by the hunting and gathering activities, the farming activities, agricultural activities, and animal husbandry activity, and even later stages, if you see, by building the towns, cities. It's a kind of a the civilization even it started. These all kind of things has changed the face of the earth, and that has in a way altered the environment, and definitely the climatic condition also has been severely influenced by the human actions. And that is one of the reasons why human beings were, this particular epoch is known in fact to have a lot of changes in the atmospheric composition of the greenhouse gases, and that has led to even the present day climate change, anthropogenic induced climate change. Because when you see since the industrial revolution, if you see, we started using more of the fossil fuels, and that led to releasing more of greenhouse gases into the atmosphere, and that we have seen for ourselves that the present day climate changes because of human action, economic activities, all related activities, whether it is use of fossil fuels or even the urbanization activity also. It all has led to what? Changing climate, because through the increasing greenhouse gases concentration in the atmosphere, and that has led to changing climate. Particularly in this particular Holocene period, very importantly, the radiocarbon dating technology that has helped us to understand the Holocene sediments and the organic remains, what exactly the past climate in this particular 11,000 years. If you see, this technology, radiocarbon dating method, was extensively utilized. And when it deeply go into the Holocene epoch, there is a different periods also there within the Holocene epoch. The early period, early Holocene, if you see, that is between 11,700 to 8,200 years, and that is basically a global warming. It's a kind of a global warming. It's the temperature was very, very high, and moist condition was prevailed, and that that you can find it in the tropical desert areas also. And in this particular early Holocene period, if you see, 3 episodes of higher sea level, when I say the temperature is very high, and that's the reason why the 3 episodes of high sea level elevation were recorded during this particular interval, in this particular period, early Holocene period, and that we can judge, deciphered using the corals, the reef building sea corals, and by analyzing those corals, we are in a position to say that the sea level was was changing constantly, was changed during this particular period, early Holocene period. When you talk about the period, in nutshell, if you see, the Holocene epoch possesses a relatively high sea level. That's a major important thing, and minimal ice cover, because the temperature is very warm. And second important point, as far as the Holocene epoch is concerned, the mid-latitude deciduous forest, and the most important thing is the population explosion. And this is about the Holocene epoch. And particularly, as I repeatedly said, that the Holocene epoch, the human action is much more than any of other organisms, and that has led to the present day change in climate. And to sum it up, today's session, we have seen the climatic condition in the geological past, starting from the Precambrian period, and thereafter we talked about the Phanerozoic also. There is a lot of changes between the Precambrian climate and the Phanerozoic period. And when you look at it, we have ended up saying that the present day Holocene epoch where we are living, it is constantly the temperature is increasing because of human actions. Thank you.